Okay, so this question is asking us to consider the graph y equals x squared plus 3. And the first part is to show that a tangent line at the point a comma a squared plus 3, that's what you, y value is what you gave yourself a in for x, is given by the equation y equals 2ax minus a squared plus 3. Right, then ask something about some specific grade points, but let's start with part 1. Right, part A. We need to find the tangent line. We need a couple of things, right? Because we're going to use a point gradient formula. Right? So y minus y1 equals mx minus x1. We've got y1, right? That's our y value at the point. And we've got x1, that's our x value at the point. So what we need is a gradient. And we get the gradient by differentiating our graph, the line that we're graphing, and then subbing in the value we have. That is m equals dy dx evaluated at x equals a. Right. So dy dx, we use our power rule, we get 2x, evaluate that at x equals a, gives us 2a. Right, so we go back to, as I said, that's our gradient for our line. So our line becomes y minus a squared plus 3 is 2a times x minus a. Now, we just want to write this now. This is the same line, right? I'll demonstrate that by doing a little bit of algebra here. Let's just take the minus sign through the bracket there, multiply the 2a through the bracket on the right. And then we'll take everything that's not y on the left over to the right. Collect some like terms. And we have what's required. So we've completed part A. We've shown that our great tangent line is everywhere given by this equation. Now part B. Part B is asking us to find the specific points where the tangent line goes through 2, 6. Right? So what we can do is we can take our tangent line and we can start to, if we put in the y value of 6 and the x value of 2, right, this is a point we know is on our line. That will give us an equation for A, which we can go through, we can go back to our curve and find the coordinates that correspond to that value of A. Right, so let's do that. 6 equals 2 times A times 2 minus A squared plus 3. 6 equals 4a, take a squared plus 3. Right, this is a quadratic for a. Let's just get it to the normal form. Right, 0 equals and I'm going to multiply everything by -1, so that it becomes a monic quadratic. And this is one we can factorize. A take 3 times A take 1. So A equals 3 or 1. Right. Those are our two x coordinates. Right. The y coordinate corresponding to that for the points where we've calculated our tangent line. Right. The y coordinate would be a squared plus 3. Right. A is our x value. That'd be 3 squared is 9 plus 3 is 12. 1 squared is 1 plus 3 is 4. So our 2 points are 1, 4 and 3, 12 are the 2 points where the tangent line goes through 2, 6. Right, the 2 points on the curve where the tangent line at those points goes through 2, 6.